right, this is an introduction to the build an atom simulation. It's got three parts. We're going to start with the atom. We're going to look at the symbol and then game. And your assignment for today is to play the game. We'll look at that last. So the atom builder, click on it. It comes up. When you start out, these things are hidden. Click the green pluses. This one will show us the net charge. Remember, we've said that atoms are overall neutral, but inside them they have positive charge material, which we now know is in the nucleus, made of protons and negative electrons, and they're neutral. If those balance, they will have a net charge, positive or negative, if they have more of one or the other charge. Mass number is another thing that was in the slides, and this will show the mass number of the atom as we build it. Here's a periodic table. The position of the element in the periodic table will be highlighted as we start to build an atom. So protons are necessary. The atomic number is based on protons. We add one proton. Protons are plus, got a +1, mass of 1, and that makes it hydrogen. We can add an electron. Electrons do not go in the nucleus. Electrons find their place outside of the nucleus. Another proton. That takes us from hydrogen to helium. We're now back to having a net charge of +1, 2 pluses, 1 minus. We have a +1 here. We'll add another electron. And again, it doesn't want to go in the nucleus. Now we have 2 pluses, 2 minuses. The mass number is 2. Remember, the mass number is protons and neutrons. Let's see what happens if we add a neutron. Element doesn't change. Charge doesn't change. Mass number goes up by 1. Add another neutron. Mass number goes up by another 1. So we add a proton. Watch what changes. We've got the element, we've got the net charge, we've got the mass number. Okay, the element went from helium to lithium. One more proton. Adding a proton changes the identity of the element. We now have one more proton than electron, so we have a net charge of +1, and the mass number went up by 1. Add another electron. After the first two, the electrons are going to go into that outer ring. Let's add some more electrons and see what happens. Apparently, we can only fit 2 electrons into that first ring. Now we've made a hugely negative thing. Add some more protons. Now there's one more box, stable, unstable. The protons are all positively charged. They stick together in the nucleus because of something called the strong and weak nuclear forces. These are very short-range forces, but they are more powerful than the electrostatic repulsion. However, you have to have the right balance of protons and neutrons for the nucleus to become stable. All right, so now we have, let's see, our mass number is 10, and we have 5 protons. 5 protons and 5 neutrons makes it stable. Let's see, we still have a charge of -1, so we can take an electron. Anyway, that's how you can put the different particles in the atom and look at how the identity of the element changes, how the net charge changes, how the mass number changes as you add and take away protons, neutrons, and electrons. There's another view of electrons. And we've also seen, and this is something that we'll come back to, that there's such a thing as an unstable nucleus, that nuclei are held together better when they have a balance, a certain balance of protons and neutrons. This one happens to have equal numbers for many of the elements, what we call the lighter elements near the top of the periodic table. A ratio of about 1-to-1 on protons and neutrons seems to make them stable. As we get to the heavier elements further down, they need higher ratios of neutrons. All right, we're going to go back and look at symbol next, because one of the skills that we're working on is writing these symbols. So we have the same periodic table in the top here showing, and we've retained our same atom, which is boron, with 3 neutrons. And now we have this isotope symbol. Now, the I don't think this was in the slides, but the charge appears in the same place that we have written the charge when we've written ions. Okay, so that should be familiar. Atomic number on the lower left, mass number on the upper left. Mass number is almost always greater than or equal to the atomic number. Larger number on top, smaller number on the bottom, atomic number. This is the one that relates it to the periodic table, tells you what element it is, tells you how many protons it has. So we can reset, and let's show stable, unstable. We can go back. So adding a proton, we have an atomic number of 1, 1 proton, mass number of 1, charge of +1. We'll give it an electron to neutralize it. Add another proton. Atomic number goes to +2. Element changes because helium has a different atomic number. Mass number is still 2. It's now unstable. Oops, I meant to give it a neutron. Oh well, at least I got rid of the charge. Neutron. 1 neutron makes it stable. The most common isotope of helium has 2 neutrons. Remember, it's helium if it has 2 protons. So it's helium whether it has 1 neutron and 2 protons or 2 neutrons and 2 protons. And you can continue to add particles and see how the symbol changes. Anytime you add a proton, you change what element it is, and you change both the atomic number and the mass number. Anytime you add a neutron, you do not affect the atomic number, you change the mass number. And both protons and electrons, but not neutrons, affect the charge. We can add a couple of electrons and get that net charge down to 0. Okay, the game. There are, how do we get this? There are 4 different parts of the game. I want you to play all 4. This is today's assignment, to send me a screenshot showing all your stars that you earned. And if you complete, I think there are 5 questions in one section. If you complete it and you don't get 5 stars, or you don't even get 4 stars, and you want to play it again, you can play it again and it will give you 5 new problems that you haven't tried before. So first game, find the element. Okay, what determines what element is? The atomic number, which is based on protons. So neutrons and electrons don't have anything to do with what element it is. Look at the protons. 10. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th element is neon. We're going to highlight that. Is it neutral or is it an ion? For that, we need to look at the protons versus electrons. They're the same. Protons +1, electrons -1. If we have the same number of each, it is neutral. You get a smiley face. All right, let's see. Second one, what is the mass number? Okay, remember mass number, protons and neutrons each have a mass of 1. Electrons have a tiny, tiny mass, so we're going to ignore the electrons and the mass number. We have 1 proton here, no neutrons, so we're going to say mass number is 1. All right. All right, in this one, they show us the symbol and they ask us to identify different things. So here, they want to know the mass number. What's the mass number? Well, this atom has a proton and a neutron, and we know that the sum of the protons and neutrons is the mass number, so we add them both up, and that's 2. And this game will ask you for different things. It's not always going to be a math number. And then this game is all mixed up. So looks like we need to write the symbol for the element having 7 protons, 7 neutrons, and 7 electrons. So protons and electrons, we know it's going to be neutral. This number here is the atomic number. That's the number of protons. We're going to make that 7. And for us, it found that element 7 is nitrogen. Here is the mass number. Mass number, remember, protons and neutrons each have a mass of 1. Electrons have a tiny, tiny mass, so we ignore them. So we're going to ignore the electrons. 7 plus 7 is 14. And check. Okay, so that is, please do go ahead and play with the atom and the symbol, and then play the game. And there are instructions in the assignment to send me a screenshot showing all your stars when you're done. All right, that's it. Have a good day.